Chapter 1, Lesson 7, Analyzing Categorical Data. Remember, statistics is the art and the science of gathering information, organizing it, and then analyzing it, and then using that information possibly to make decisions in the future. So, last time we talked about organizing it and graphing it so that we could visualize it. Today, let's see how we can make sense of those visualizations. So last lesson, I also mentioned the word frequency a few times. Frequency just means the number of times something shows up. An observation is another way of saying a variable value. So some of the observations that I made, and you can still see some of my marks from my dot plot in the last lesson. Some of the observations I made were the colors of the robots. Yellow, purple, green, red, white. If you want to make a chart that shows those frequencies, you can make a frequency table. Usually you're going to have some sort of identifying the individual, or possibly, not the individual, the variable. So like colors, red, blue, green, white, black. And then the frequency, you show that it shows up 6 times, 9 times, 4 times, 2 times, 7 times. And that would be your frequency table. Now, a relative frequency table is where you make it into a percentage instead of a raw number like this. So if it was 6 out of 10, then the relative frequency we could add to one side and then make 6 divided by 10 into 60% or 0.6. A lot of the time you may see relative frequency tables in whole percents, and sometimes you'll be seeing them in decimals, which are equivalent just by, you can turn a decimal into a percent by multiplying by 100. You can turn a percent into a decimal by dividing by 100. So pie charts. Pie charts are circular graphs. They just show percentages relative to, or relative frequencies. They have to add up to 100%. And a lot of the time, we're just saying that this proportion is what happens. So they are oftentimes not going to be a great way to visualize most of your data, especially if it's anything more than just simple frequency. Bar graphs are oftentimes preferred. They are often used to visualize both frequency and relative frequency. And one more note on the back. Bar graphs. There's some good graphs and some bad graphs. There are some little rules that need to be followed. Good bar graphs give each bar the same width. One of the things that our minds do, one of the things that our brains do, is we lock on to actually the area of a shape to figure out its size. So if one is skinnier and one is wider, then even if the wider one is taller, people will sort of assume it's way bigger, or even if the wider one is smaller, people would assume that it's actually not as small as it is. They will assume that the skinnier one is probably smaller. You also need to start with the y-axis at 0. You want to see what 0% looks like, so it goes all the way up so that you're not sort of cutting off the lower numbers at the knees a little bit. Again, make sure that they have the same widths. They should also really just be bars, not pictures, because pictures, when you grab the corner and sort of resize it up and down, it then makes your bars end up having different widths and different heights, which again, we want your x-axis to be pretty much even and the same. And then your y-axis just needs to start at 0 and count consistently.